Hello, Accelerated Chemistry. This is Mr. Spurk, and this is your Chapter 15, Section 3 notes all over heterogeneous aqueous systems. So why are some sunsets red, or even some sunrises? The atmosphere contains particles of water and dust, and as sunlight passes through the particles, it is scattered. However, not all wavelengths are scattered to the same extent, which causes the different colors. So we're going to talk about suspensions. What is the difference between a suspension and a solution? A suspension is a mixture from which particles settle out upon standing. A suspension differs from a solution because the particles of a suspension are much larger and do not stay suspended indefinitely. A solution is a homogeneous mixture. Suspensions are heterogeneous because at least two substances can clearly be identified. The difference between a solution and a suspension is easily seen when the type of mixture is filtered. The next thing is colloids. A colloid is a heterogeneous mixture containing particles that range in size from 1 nanometer to 1,000 nanometers. The particles are spread or dispersed throughout the dispersion medium, which can be a solid, a liquid, or a gas. So here are a couple different types of colloids. In the dispersed phase, so if we're in the gas phase and you see a liquid, that's going to be foam. You might see this when you pour a pop into a glass. Well, the example they give here is whipped cream. A gas dispersed in a solid is a foam, like a marshmallow, and so on and so forth. There's a few other examples there you can read through. Colloids have particles smaller than those in suspensions and larger than those in solutions. These intermediate-sized particles cannot be retained by filter paper as are the larger particles of a suspension. They do not settle out with time. A good example of a colloid is milk. Milk has these little tiny particles in there that they do not settle out, and you cannot get them out with filter paper. The Tyndall effect is our next topic, and you cannot see a beam of light unless the light passes through particles of water or mist or dust in the air. So as I talk through this, make sure you're looking over here on the right side, the solution, the colloid, and the suspension. These particles scatter the sunlight. Similarly, a beam of light is visible as it passes through a colloid. As you can actually see the beam of light as it goes through the colloid because there are particles in there. The scattering of visible light by colloidal particles is called the Tyndall effect. And suspensions also exhibit this Tyndall effect, and the particles in solutions are too small to scatter the light though. So it just kind of spreads out throughout the solution, or it goes through the solution. Brownian motion. Flashes of light or scintillations are seen when colloids are studied under a microscope. Colloids scintillate because the particles reflecting and scattering the light move erratically. Brownian motion is caused by collisions of the molecules of the dispersion medium with the small dispersed colloidal particles. These collisions help prevent the colloidal particles from setting. Coagulation. Colloidal particles also tend to stay suspended because they become charged by adsorbing ions from the dispersion medium onto their surface. Now, adsorbing is different than absorbing. Adsorbing means that it attaches to the surface of something else. All the colloidal particles in a particular colloidal system will have the same charge, although the colloidal system is neutral. The repulsion between the like-charged particles prevents the particles from forming heavier aggregates or heavier clumps that would have a greater tendency to settle out. A colloidal system can be destroyed or coagulated by the addition of electrolytes. The added ions neutralize the charged colloidal particles. The particles can clump together to form heavier aggregates, and then they settle out from the dispersion. Emulsions. An emulsion is a colloidal dispersion of a liquid within a liquid. An emulsifying agent is essential for the formation of an emulsion and for maintaining the emulsion's stability. Oils and greases are not soluble in water. However, oils and greases readily form a colloidal suspension or dispersion if soap or detergent is added to the water, because they'll grab onto the soap that's in the water because the soap is nonpolar. So the summary of solutions, we have the particle type, the solution, the colloid, and the suspension. So these are just different things that you might want to jot down in your notebook. Kind of breaks it down into the three main parts. In review, a suspension differs from a solution because the particles of a suspension are much larger and do not stay suspended indefinitely. And colloids have particles smaller than those in suspensions and larger than those in solutions. As always, all the information on these Google Slides has been acquired and adapted from Pearson Chemistry 2012 edition of the textbook, the resources CD, and pearsonchem.com. Have a good day, everyone.